everyone. In today's video, I'm explaining about carbon-carbon pi bonds. So it is simply indicating that unsaturated hydrocarbons. So here about unsaturated hydrocarbons, we'll discuss alkenes and alkynes mainly. So we know already what is a pi bond. Pi bond is nothing but which is formed by the side-wise overlap of orbitals. We know sigma bonds forms by the end-on end overlap of orbitals. Now you can see here in alkenes you can observe down one sigma bond, up one it is a pi bond. In alkynes we can see triple bond. Whatever down bond you can see that is a sigma and next two bonds are pi bonds. Okay, so now let us see more about alkenes today. So alkenes are nothing but they are hydrocarbons containing C double bond C in their structure. And here you can observe the tetravalency of carbon is satisfied by the presence of a pi bond. So we know already carbon is an element which is having tetravalency in the periodic table. So here tetravalency is satisfied by the presence of a double bond or sigma or pi bond. You can see carbon here, around carbon you can see four bonds. Here also in triple bond you can see around carbon there are four bonds. Okay, so these are also called as olefins. So you heard many times alkenes are called as olefins. Olefins are nothing but oily forming liquids. So whenever these alkenes are reacting with chlorine or bromine, like lower members of alkenes, like alkenes containing less amount of carbons, they reacts with chlorine and bromine to produce oily liquids. Now you can see ethylene on reaction with the chlorine or bromine, it produces a dichloroethane or dibromoethane. So this is a liquid form which gives oily appearance. So because of oily forming, we can call them as olefins. Now alkenes have a general formula that is CnH2n. You can observe this CnH2n. Let us substitute the number of carbons in this particular formula to find out the structure of the particular alkene. You can see here two carbons. I'm taking first two carbons. Our first member is nothing but ethylene. So I'm taking two carbons and I'm substituting in the formula of CnH2n. So in place of N, keep this 2. C2H, 2 into 2. You are getting a C2H4. So you can see the structure, C double bond C. Around each carbon you can observe two hydrogens. So after writing the structure, you observe around carbon there must be four bonds. Okay, around carbon there must be four bonds. So this is the first member in the alkenes. We call it as ethene or ethylene. Next coming to third carbon. So three carbons I'm taking and I'm substituting in this formula C3H2 into 3. So we are getting a C3H6. So firstly write the carbon chain and you can keep double bond anywhere. After keeping double bond, start attaching hydrogens. So while attaching hydrogens, you should see that around carbon there must be four bonds. So firstly I'm writing two hydrogens to the first carbon. So after that you check there must be four bonds around carbon. Next you see I kept one hydrogen here. So here two bonds, here one bond. So around this carbon you can observe there are four bonds. So this is a structure of propene. You can observe it is a compound where you can see the formula C3H6. Next coming to four carbons. So four carbons you are substituting in the same formula again. C4H2 into 4. You are getting a C4H8. So now write the structure again. Same, write the carbon chain first. You can keep the double bond anywhere. After keeping a double bond, start attaching the hydrogens. You can see here, firstly I wrote three hydrogens. Around carbon there are four bonds. Here you can observe around carbon there are four bonds. So around carbon there are four bonds. Here again around carbon there are four bonds. So this is the structure of butene. Okay. So next coming to pentane. So that is nothing but 5 carbons will be there in pentane. In pentene, not pentane. So 5 carbons I am substituting in the same formula. C5H2 into 2 into 5. I am getting C5H10 formula. So now I am writing the structure. So this is the structure of pentene. So where you can see one double bond and totally after this you count hydrogens. There are totally 10 hydrogens. C5H10 formula. So like this you can continue 6 carbons, 7 carbons, like that you can continue. So this is the example for structure of alkenes.